Hello, this is Late Night Code. My name is Ian Riley, and I'm really excited to have you join me for this EP0 on competitive programming. So in this 0th episode, we're going to be talking about how to get into the space of competitive programming. And this largely requires three things. The first thing is we need to pick a language. The second thing is we need to look at tools. And the third thing is we need to find problems. So let's go ahead and jump over to that real quick. So the first thing is that we need to be able to pick a language. Now, if you're already familiar with programming, then one of the best resources that I recommend is Learn X and Y Minutes, where you can actually get an overview of dozens and dozens of languages. For example, let's go over to the overview on Rust. If we scroll down here and click Rust, here you have a program written in Rust that actually shows you most of the language features that are actually available in Rust, and can be a really good syntactic and semantic guide to get you familiar with the language. Now, if you've never programmed before, this will probably be pretty unfamiliar to you, and I don't really recommend Rust as a first language. If you need to actually learn the language and would like more interactive material, if you want to learn Rust, I really recommend going to the rustling.org Learn site, where you can read the book, do the Rustlings course, or check out other Rust examples, depending on what works for you. If you really like exercise, I very much recommend the Rustlings course. Alternatively, if you've never programmed before, or if you're working at the high school level and you want some resources on Java, maybe you're also at the college level and that's what your college uses, that's what we use, then there's a great Learn Java resource on Code Academy, as well as several other tutorials that you can find online. So these are resources that help you get started in your chosen language. Other potential languages that you could do and follow along with. Now, note that while we'll be solving problems in these languages, I'll be communicating the ideas in a way that should be transferable to any language that you want to implement it in. Now, a lot of untimed competitive programming, you can use any language, but if you're doing a timed contest, something like USACO or ICPC, you're actually fairly limited. For high school students competing in USACO, you can use C++, Java, or Python. Those are your choices. And for students competing in ICPC, your choices are those, as well as Ada or Kotlin. Now, full disclosure, if you're going to be choosing Ada, Kotlin, or Python, while they can be submitted to contests, the contest hosts don't actually guarantee that you can pass all of the problems in those languages. So some of them might get what's called a TLE, or a time limit exceeded. So effectively you have a solution, but it takes too long, because these competitive programming contests do test you on your ability to get the right performance for your solutions. Java and C++ do have guaranteed solutions, but in Java, you may need to do some finagling to make it work, but largely you'll be fine. So C++ and Java tend to be the most preferred. We'll be using Rust because I really want to give it a go, and I think it'll be kind of fun and kind of new for people who are already experienced. And then also Java because, again, high schoolers kind of need to use it because that's what the AP school board tests them in. Now that we've selected a language, the next thing to talk about would be tools. Now for this series, I'll be using AstroNvim. I really like working from command line, and I really like using NeoVim in particular. Astro for me has just been a comfortable way to kind of go ahead and get started with all the basic plugins that I really like. File Explorers, Fuzzy Finds, Mason, and things like that. And it's pretty easy for me to go ahead and configure it. In fact, I have a repo on GitHub with basically all of my configurations of FT plugins and user configurations for AstroNvim. So for me, it's pretty easy to just install AstroNvim, then git clone that repo, and I'm off to the races, and it's the same experience on every platform. So I really like this. And yes, I could have done the same thing with NVim, but AstroNvim kind of just helps me get started. And so this is what I generally like, and it can be a good way to get into NeoVim if you've never used that before. So for people who are experienced developers, college students, graduates, and things like that, if you've programmed heavily, maybe you're in high school and you have programmed heavily, if you have that under your belt, I really recommend moving over to command line, and in particular using tools like Vim or NVim in particular. I think you're really, really going to enjoy it. It's a little bit upfront, you're gonna have to invest some time kind of getting used to the workflow, but once you do, it is well worth it. Now, for people who are just not ready for that yet, or for first-time developers, I very much recommend Visual Studio Code, because this can be a one-stop shop for programming. Basically, you install the software, then you install the extensions for your languages. There may be a few other things you have to install. For example, if you're working in Java, you're going to need to install Java on your system. So you may have to do a few other things, but it's relatively easy to get started, and it will help you with the process. So Visual Studio Code is what I'd recommend. Now, for those in high school, a lot of high schools, at least here in the United States, do provide students with laptops, largely Chromebooks, and they may not allow you to go ahead and install the software. You may be in another space where you're not able to install the software, maybe working out of a local library or something. In that case, I'd really recommend that you check out repl.com. This is a site where you can basically spin up your own virtual environment by clicking Create REPL. You can choose a language like Rust or Java or really any other language as well. Python, right? Oh, I misspelled Python. Oh, okay. It's not a fuzzy finder. Okay, so some things could be done a little bit better there, but I can guarantee that you'll be able to work in these languages and be able to produce solutions and download them to be able to submit them to the contest site. So this can be another really great alternative. And again, for those that want to switch over to command line, if you've never used Vim before, then this site can be really helpful. It's called Vim Genius, and it can teach you a lot about using Vim. For developers, again, I cannot stress enough, Vim, while it's very old school, can be an absolutely positive and productive resource for you. Even if I have to work in Visual Studio Code, I turn on Vim bindings. If I work online through contest site like HackerRank, for example, I use Vim bindings because Vim makes me more productive and makes me a faster developer because I keep my hands on the keyboard at all times. And I think that you'll really, really enjoy it if you get used to it. So generally my recommendation is start with Visual Studio Code. Then once you get into it, later on, turn on the Vim bindings through the Vim extension for Visual Studio Code. Make sure you go to Vim Genius first. And then when you're used to it, switch over to command line with something like AstroNvim or your own NeoVim setup. It'll be well worth it. So now we talked about 1, languages, 2, tools, 3, how do we find problems? Well, the first place to look for problems is on sites and platforms that advertise themselves to help developers prepare for technical interviews. These would be sites like LeetCode, sites like HackerRank, almost said Dashboard, and there's other ones like TopCoder, CodeChef, and many, many more. If you just look up platforms for technical interview prep, you'll find dozens of them. LeetCode and HackerRank are the ones I most recommend because I tend to see these be used for technical interviews, but I'm sure there are many more. And if you've done technical interviews in other sites, please post those in the comments below. I'd love to hear from you. For the contest that students will take, there is Caddis. Now, Caddis has become the standard for ICPC, and in fact, all of the world's finals problems, as well as other regional problems and national problems, are stored on Caddis. And so you can actually go there and solve in a variety of languages problems that have been used for competitions for several years now, which is really, really exciting. For the high school students, we have the USACO, which is actually where the contests are hosted. And we can actually go to the contest site and see the results, which is actually all of the problems that have been used in these contests for several years, dating back all the way now to the 2011-2012 season. And so you can access all of these problems here, and we'll be using those as well. There's typically about 3 problems per category, and categories go from bronze to silver to gold and to platinum. And now, by the way, if you're thinking because this is a high school computer contest or algorithmic contest that the algorithms are generally easier, you would be mistaken. For example, many competitive programming problems that are used for technical interviews, and again, I want to stress that I'm talking about programming problems used for technical interviews for graduate developers, would fall in the bronze and silver category of USACO, which means that if you are a developer who's thinking that these might be beneath you because they're high school problems, it means that there are high school students right now competing on an international and national stage, solving platinum and gold problems that are harder than many of the computer programming problems that you will do for a technical interview. So these are quite difficult at their highest stages and also a ton of fun. And also for advanced preparation, some of our graduates who have competed at IOI and done very well for the United States have actually created the USACO.guide, which is a preparatory resource to help students prepare. Now, for college students, I'd also really recommend that you check this out. And for developers who want more learning resources about algorithms and data structures, also this can be really, really helpful. We effectively don't really have another resource like this right now. although I'm hopeful we'll see more in the future. But this is really cool because it will actually give you problems and breakdowns of how you can actually solve those problems in multiple languages. So really, really great resource that I recommend everyone use. So those are our three things, our languages, our tools, and where we can find problems. And you'll see those featured in all of the problems that we solve as a part of this series. So that's all I have for you as a part of this episode. So until the next one, have a great night, and I'll see you then.